All right. In other words, you're going to set up like two columns, set up area. This is real land. We're going to call this Bizarro land. Means nothing to you, but I like it. Bizarro land. It's where everything's upside down and inverted. So, if you look at this, in real land, it says f of x equals x to the third. So over here, I've got, and then I want to find it, I want to find the derivative. Let's call this g of x to be consistent at 27, right? That's what I want to find. Now, at this point in your mathematical career, what would be the easiest way to do this? Find the inverse, do the derivative, call it a day, right? I'm going to give you functions in a little bit. You can't do that on. So we're going to practice it the hard way right now, or the different way right now. So what do I need to know? I need to know the derivative at some place. So what is the derivative over here in Bizarro land?
That's real land.
Sorry, real land. Thank you. What's the derivative?
2x or 3x squared.
3x squared. Love it. So far, so good? Now you know what point I need to find it for. To find what point, I'm going to have to do what? Well, if I want to find 27 here, that would be a y value here, right? So I'm going to say I'm looking for the point, which is something 27. Agreed? So I'm going to put 27 in, not for x, but for y. So put 27 here. 27 equals x cubed. What do I get for x?
3.
I get x equals 3.
So can you plug in 3 to that?
So now I'm going to plug in 3 to here.
And you get 1 over that, and that's the answer.
Hold on. Yes. 3 squared, and I get what? Well, that's inconvenient. What do I get?
9 times 3.
27. So what is the derivative of the inverse at 27? 1 over 27. Yes, ma'am.
I know that it's like, okay to be confused.
You should be confused, yes.
But I'm just confused on why g prime of 27 is what x.
F of x is not equal then.
Well, like,
We know we want to find the derivative at 27 of the inverse of this function.
but x equals x, so now we're gonna have it equal to
Okay, but I said of the inverse. I tried to make it as clear as I possibly can. We're talking about 27, where x is 27 in inverse land. Okay? So that doesn't tell us what it is in real land. In real land, we're going to have to flip it, right? Because x and y are going to switch. We're going to switch x and y whenever we cross this boundary, right? Back and forth. So we're going to cross the boundary back and forth. We need to make sure that whenever we go from one side to the other side, we switch it. Hardest part of this problem oftentimes is interpreting which x did they give you. You know what I mean? They're going to say add x equals 2. And then you guys have to diagram the sentence, figure out whether they meant the first function or the second function. As bad as that is. And I'm trying to give you easy problems. It's awful what they can do to you with that phrase. But as long as you understand it's 1 over, and you understand you have to switch x and y going back and forth, these problems are actually nice. But it takes a while to get used to them. So we're going to try another problem. So try more normal. So I want you to try to find, so what is the derivative of g of x? Oh, that's actually more normal. So that's just doing it. This is just prove it works. So prove it works right now. Yes, sir.
So when they say find the derivative of the function blank at this point, is that always the g of x side?
Do it the normal way. This is the normal way again. If I assume the inverse is 1/3, I got x equals 27. So now I'm going to go ahead and do the problem. I'm going to go ahead and go g prime of x would therefore be equal to 1/3 x to the negative 2/3. That's the normal way to take the derivative, right?
But I thought you said you had to switch them first.
Okay, but I'm saying, okay. Let me try this one more time. Where it says more normal, that problem I want you to do it the old-fashioned way, the way we did before we did inverses. I'm just trying to prove this is 1 over 27,
Oh, okay.
right? That's all I'm going for here. I guess I'll get that off of there now. So just try to prove it works, right? In a situation where we can prove it, right? Because in a little bit, we're going to do a bunch of these where I can't prove it works or not. At least not right away. Does that make sense? So we're going to do a bunch of these where you can't, where you have to use the inverse because you have no option. You're dead in the water without it. Oh, right in the eyeballs. I'm going to set up my inverse land. Just because the problem says arc sine, I'm like, oh. And I'm going to know y equals arc sine. I'm going to call it my inverse. I'm going to put it in bizarre land. Now, it doesn't matter which side you put it on. I put it on bizarre land because arc sine looks weird to me, right? B land. Normal land. Great. Now, in order to do this, I'm going to have to figure out what the inverse of y equals arc sine of x is. What is the inverse of y equals arc sine of x? Sine x. And again, I could do this by switching x and y and solving it that way. But y equals sine x. Good deal. Now I'm pausing there. Is everyone with me? This is where you're really doing a problem right now. Now, I wanted to know when x was root 2 over 2, is that in bizarre land or normal land?
Wait, wouldn't arc sine be a normal land?
Hold on a second. That question. Which side would it be on? So they asked us to find this function at x at root 2 over 2. Isn't it with this side? You have to get that. That's the part I'm trying to go for here. Okay, I'm not trying to bully you into an answer. You need that idea. If you've got a question, ask it. Are we good? Look around the room. Now I'm going to back up a step because Walker asked a backwards question. What?
Don't arc sine get you only put in like that. Root 2 over 2.
Yeah, that's another way to hint. That's cheating, though. You shouldn't be thinking that way, right? Because I could technically not. I mean, that could technically be an angle, but it probably isn't, right? So I'm going to pause my bizarre land. I got my inverse land, or my regular land. So now I'm looking at these things. Now, what do I do from here? Derivative of sine x. What is the derivative of sine x? Cosine x. Love it. All right. What else do I need? Got it. What else do I need?
No, just
I know you walked in halfway through. You've got almost no hope at all. Get you in a moment. Just let me see if I can get everybody through this mess before we get done. Okay? I need to know where I'm going to take it, right? What value of x do I put in here? Do I put this in?
No.
No, I have to switch this first, right? So I'm going to go over here. I'm going to go, well, I put in root 2 over 2 into this function. What do I get for y?
0.7854.
No, you don't.
That's what it said.
We should get 45 degrees. Oh, no, not in this class. We should get pi over 4 in this class. Right. So let me pause for a moment.
Yep, that's my answer.
Pi over 4? Or if you put in your calculator, you get point something, 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 which means pi over 4. Agreed? So now, what is this point in normal land?
That's the x.
It's going to be, that's going to be x. So go pi over 4, comma, root 2 over 2. Agreed?
Yeah.
So now what point am I going to put in this function here? What am I going to put in the derivative? What value of x? Pi over 4. Which is going to give me, ironically enough, root 2 over 2.
That's not right.
Which means the derivative, let's call it g of x. Does it say f of x in the problem?
No.
Oh, we should be consistent. Make it f of x then. Then f of x equals 1 over, I should put f of what's the point? Root 2 over 2 equals 1 over root 2 over 2.
Or 2 over root 2.
Flip and multiply, I get 2 over root 2, and multiply top and bottom by root 2. I get 2 root 2 over 2, which is root 2.
Oh,
You actually
that's
could
right.
stop right here, according to 80%. I'm offended, but that's okay. I'll never see your test. Yes, there's an infinite number of points. I'm not going to go there.
So
Thank you. Not going to go there.
Have you just
Not
showed
right
us?
Not right now. Not right now. No, let's not do that.
Wait, have you showed us 4 problems that happen to have like both our root 2 over 2 and pi over 4, or 27 and 3? Like, are they always going to be the same 2 points, just flipped?
Yes, they always said flip it because this is where again in normal land it's xy. Over here it's going to be yx.
Yeah, but I mean,
Because we're switching xy. That's all inverse means.
wait, I didn't ask that question correctly. Wait, like y prime is cosine pi over 4, and that one is okay.
Okay. Now, Walker, to your first question. If I just replace this with normal land and replace this with bizarro land, it doesn't change anything.
Well,
Right? I'd start here. What's the inverse in bizarro land? It'd be this.
Yeah.
I'm plugging root 2 over 2. I get root 2 over 2 pi over 3. So in bizarro land, I have to flip them.
I already did it the other way. So.
The other way? It makes sense? Okay. Now, Enrico's question. Okay. Well, we're gonna work on the next one together, so that'll work. So we'll try this out.